Okay, so this is the 2018 paper, Unified Physics. So I'm just going to quickly go through the answers. So for this question, you measure the voltage and current using a voltmeter and ammeter. You reduce the heat loss by using less current. Stir the water for equilibrium and weight. Use V equals IR to find R. The straight line will be when you plot a graph of R against T. RK is the gradient, R0 is the y-intercept. For this question, use the equation P equals IV and V equals IR. Combine them together, you get P equals V squared over R. So your resistance is 52.9 ohms. For this question, you need to look at the diagram. The length of the whole thing is 18 centimeters, but the distance between the centers is 1.5 millimeters. So you need to work out the number of turns, and then the number of turns times 2 pi r will give you the total length of the wire. And you get 528 centimeters. This one uses R equals rho L over A. You want to work out A, and just rearranging for A, because you've worked out the length, you've worked out R, and you're given rho, and you want to work out A. You look at the table, once you've worked out A, you get 28. For the next bit is SHM. So you got A equals minus omega squared x, and you know that omega is 2 pi f. So you want to work out the maximum displacement. In this case, you want to work out A. So A is equal to 0.05 divided by 4 pi squared f squared. And whatever the answer is, that's your answer. You're given f is 0.5, so just put all the numbers in. The next question, explain why the natural frequency of the damper system must be about 0.15 hertz. So when it is 0.15 hertz, this gives you maximum acceleration. Maximum acceleration gives you maximum amplitude, and this gives you maximum energy transfer. And then you just need to state what resonance is. This is when the driving frequency is the natural frequency, and this gives you resonance. For this question, you know that A is equal to minus omega squared x, and then you just equate the two together. So omega squared equals k over m. K is m omega squared, and again, just going back to omega equals 2 pi f, you get 5.86 times 10 to the 5. For this question, because it's asking you for the energy transfer to the spring, that is half kx squared. In this case, x is the amplitude. So you just put all the numbers in because you worked out the amplitude in the previous question. 1.47 times 10 to the 5 joules. For this question, why the stars of equal mass must be diametrically opposed. You need to say that the gravitational force is the centripetal force. The force between them lie on the diameter. For this question, you're given all the data already, so you need to work out R. You're given 2R, so just work out R, that's half of that. You know that G is 6.67 times 10 to the minus 11. The period, convert the period into seconds, and then rearranging, you get m equals 4.4 times 10 to the 30. But because it's asking you for in terms of the mass of the sun, you're given the mass of the sun, just divide the two numbers together, you get m is 2.2. For this question, you need to use the equation delta lambda over lambda equals v over c. But how do you work out v? V is equal to 2 pi r over t. So rearranging, so once you've worked out v, you put it into this equation, the Doppler effect equation. Once you have your v, you can rearrange for delta lambda. And delta lambda equals v over c times lambda. For this question, you need to draw the orbits. So the bigger mass has a smaller orbit, and the smaller mass has a bigger orbit, because the center of mass is that big dot there. Explain why the smaller mass travels faster. It is because the smaller mass has a larger circumference, has a bigger radius, it has the same period, so using the equation v equals 2 pi over t, v will be bigger. For this question, you need to use half mv squared equals mgh. Now in this question, you've got two different values for m, because the trolley is attached to the small mass. Because both of them are moving, you treat it as though it's one system. But on the right hand side, because only the small mass is changing height, so you've got two different m's. So this m is the 0.8 plus m, because they're both moving together, but then the change in height is only this small m here. So half brackets 0.8 plus m times v squared equals mg times 0.6, and then rearranging, you get this equation here. For this question, you just you just square it, right? So you square the 2.22 because it has to be 2 decimal places, so it's 4.93. And then to work out the absolute uncertainty, because it's v squared, you need to do 2 times the percentage uncertainty of v. So 2 times 0.05 divided by 2.22. And then because this times 4.93 gives you 0.22, and then that will give you your absolute uncertainty. For this question, you just need to rearrange and then equate with y equals mx plus c. So here, this is what I've done here on this side here. So y is v squared, m is m divided by m plus 0.8. So your gradient is 1.20g. For this question, you need to work out the best gradient and the worst gradient, work out what g are for each of those, and then your absolute uncertainty will be g2 minus g1. Here, this question says, because the trolley did not pass at right angles, what's going to happen? Now, if it doesn't pass at right angles, it will be a shorter length. Shorter length meaning that it will be faster. Faster means steeper gradient. Gradient means that g is higher. For this question, the flux in the coil is changing because if you look at this diagram here, the direction of the lines will change. And so because you're doing the rate of change of magnetic flux, this is EMF, right? So the rate of change of magnetic flux gives you EMF. And because the flux in the coil changes direction, it is alternating. Because there's a change in magnetic flux, and this changes direction. In this question, the dotted line is MBA, and whenever you do EMF is equal to the rate of change of flux, you're basically differentiating. So if the flux linkage, the dotted line, is sine x, you want to differentiate, and that becomes the negative of that. So when you differentiate sine x, you get cos x, and the graph you want to plot is minus cos x. This one used is just rearranging the formula. So V0 equals 2 pi f times NBA, because flux linkage is NBA, but you want to work out magnetic flux. Magnetic flux is just BA, so you want to rearrange for just BA. The unit for magnetic flux is Weber. Okay, for this question, a transformer question, you need to have an AC. Why? Because for a transformer, you need to have an alternating current. If you don't change the magnetic flux, you're not going to get an EMF. So you have to change the current direction or changing the voltage direction. The output needs to be connected to a voltmeter or oscilloscope. Keep the current constant. You're changing the frequency and you're measuring the voltage. You measure the period on the oscilloscope. You know that F is 1/t. You plot V against F, and this will give you a straight line. For the photomultiplied tube, this the critical angle. So N1 sine theta 1 equals N2 sine 90. For the critical angle, this is when the theta 2 is equal to 90. So rearranging for theta, you get inverse sine of N2 over N1. This gives you 36. Total internal reflection, and theta is greater than 36 for that to happen. For this question, E equals HF or HC over lambda. You need to convert the joules into electron volts. So to convert from joules to electron volts, you need to divide by 1.6 times 10 to the minus 19. This gives you 2.8 electron volts. My actual answer was 2.7626. And then here you just take away from 2.3. This gives you 0.46 electron volts. This is very small compared to 100 electron volts. And then for this question, because 2,000 photoelectrons, and then here it says the total number of electrons collected for each photoelectron is 4 to the 9. You times those two numbers together, and then you got the total charge is N times the electronic charge, and then using the equation current equals charge over time, you get 0.0336.